When we drive a car, do we think every detail the car has? Do we think every part? We don't, right? Instead, we just think about steering wheel, pedals, and dashboard. But the details of the car still matter. So somebody has designed them and made them work together. If we run our networks manually, we need to think way too many details in daily operations. But instead, we can model our network services, and let automation run those models for us. When I started my network automation journey, I joined a team of network engineers and developers, and we were supporting special purpose media network. So basically the network was connecting studios to the media delivery systems. There were high demands, bandwidth-wise, feature-wise, and scalability-wise for the network. The team had already left behind the manual box-by-box configuration era, at least partly. They had Netbox as their source of truth system. They had data on it, and they configured their network based on that data, at least partly. And at that point, we started to think how to make it scale. And we identified these two problems. The first one was that we were playing with way too many details in daily basis. So it kind of didn't make a sense that we have moved from box-by-box manual configuration to some centralized quote-unquote automation system, but still playing with all of the details every day. So we wanted to fix that. The other one was that we had way too complex configuration pipeline. So when we take the data from the netbox and deliver it to the network devices, that's what we call configuration pipeline. In that case, we had it in Ansible, and that playbook was getting extremely complex to handle. So basically, we were expecting to see some arbitrary tags in netbox, and in order to trigger some more configuration on the fly when pushing to the network devices. So that was something we wanted to fix as well. In other words, we had only inefficient way of putting data into the netbox and only complex way of getting it out. So this presentation is more about this input part. For that, we got solution from abstractions. So we wanted to get a higher level of abstraction for our network services. For the outbound part, the solution was what we call straight pipe, which just means that no data modifications in the configuration pipeline whatsoever. Now we can still modify the syntax of the data, but not the content of the data. This is how our automation stack looked like. So from top to bottom, we started by adding the level of abstract services, where we modeled our network design. In our case, that's extensions in a netbox plugins. And when you add a service, by the way, starting next slide, you will see the practical example, but when you add a service in this level, it will populate the data to the next level, to the detailed state of the network level. So basically to the netbox as the native netbox data models. And at that level, we have complete picture in the database format, how the network looks like. So we just transform that data into the device-specific format. It might be CLI in some cases, it might be Yang models in some cases, and it's depending on the vendor. And then we just deliver that to the network devices. So what in practice? So let's take a first example. And by the way, this is just one example of abstract service model. It can be anything, like it can be brand side, if that's the relevant for your business. It can be even end-to-end network security policy, as what we are working with one customer. In this case, it's virtual network. That's kind of a term we just invented. Basically, it means layer 3 VPN in MPLS or BGP EVPN network, and its connections to customer side. But the point in this slide is that all details highlighted in green are details which needs to be correctly allocated and correctly in place in order the service to work in high quality. So how to make this model abstract? This is how we did it. So we split the problem in two parts. The first one is a virtual network. The second one is MPLS site, and they have relationship. So one virtual network can be connected to multiple MPLS sites, and one MPLS site can have connections from multiple virtual networks. Now in this slide, we have just a couple of green parameters. This is abstraction. We hide the details under the hood. They are there, you can explore them, but you don't have to remember them when you are provisioning service like this. And in practice, it looks like this. So this is our private plugin for Netbox, and specifically adding a new virtual network. In this form, you have just two mandatory parameters, name and template, reference to a template. And template is yet another model. It's just for offloading the details from this form to somewhere else and make them reusable, so that network engineers can make different templates for various use cases. In addition of those two mandatory parameters, in this form I have filled the MPLS site. So I have selected to attach this virtual network to that Acme site too. And when I hit create, lots of details gets added into the netbox under the hood. In the left-hand side, for example, AS number for local AS purposes, we didn't tell any AS number. It was actually allocated from the ASN range of the template referred, next available AS number. On the right-hand side, we have the information about the connection to the Acme site too. And here we can see that there are lots of things. VLANs got created, prefixes, loopback VLAN and sub-interfaces got created along with their IP addresses and all of the details they need. And since last month, it has been possible to create, for anyone to create visualizations like this. So we released this Ninja plugin for Netbox, which allows you to generate diagrams based on the Netbox data. So this has been rendered on the fly. When you refresh the page, it will be up to date based on the Netbox data. It's also not just static diagram. You can click those devices and prefixes, interfaces, and get to their respective Netbox pages. So if you got interested, take a look to that. Just last week, we integrated this to the Grafana so that you can have fully dynamic dashboards for your network services, like literally 1 minute after they have been created, reflecting the telemetry on top of these diagrams. Anyways, now we have added one instance of a virtual network, and then we are going to push that to the network devices. So first of all, we can see the summary of different diff lines, basically what's going to be added and deleted. In this particular case, 500 lines of configuration. remember, 3 parameters, 500 lines of configuration, everything perfectly in place. And you can explore all of those 500 lines if you want to, line by line. And when you are happy, you just hit the push button, hit the gas and click the push button, and the change is deployed into the production. So I have been talking now a lot about these abstractions. But how do we design them? So this is roughly our design process. So it's kind of first we kind of split the problem in parts, and we decide the modules, and then we decide how they are relating to each other. Then we design data model for each part, their fields, types, and references to other data models, logics, how to create them, what to allocate when creating them, and such. What to do when delete them, what to do when change them, what is allowed to be changed, and so on. And usually it's kind of a back and forth between these 2 steps for a while, like top to bottom, bottom to top, until they match. After it's designed, it's time to implement it. And then we just implement that as a Netbox plugin in Python code and apply all the standard software engineering principles, such as writing tests and so on. And then it's deployed into the production, and then we take care of possible migrations needed for data. So there are a couple of lessons learned along the way I want to mention. There are many, but these are the main ones. The first one is get rid of arbitrary rules. I mean, we as network engineers are really good at inventing crazy rules. We are coding things into the IP addresses and VLAN IDs and stuff like that. I have seen people coding their shoe sizes into IP addresses. Just kidding. Anyways, not nearly all of those rules are necessary in automated world. Some are, for sure, for clarity, but not all. So if you try to implement all of those, the automation becomes complex as well. So it's good time to get rid of those. The second one, follow declarative model. So like 1 year ago, I learned these 2 models, imperative versus declarative. And well, imperative means that we define step by step like how things are done. And declarative means we just define the outcome and let the system figure out how to get there. And this is super important. Like in our case, we have a really simple way of implementing the declarative model in the configuration pipeline, especially. We just generate the entire configuration of a network device, of a switch or router, and when we push, we replace the entire configuration of the device. The device itself figures out what to add and what to delete. We don't have to. We don't have to think about deletions, for example, at all. This is just our intended state of the network, of your configuration, and it's the simple way. There are other ways, more sophisticated ones in the industry, but this is a simple one. Third one is that make models as generic and flexible as possible. So when we started this journey, we tend to make the models kind of hard-coded and case-specific. And we along the way, we learned how to make them more flexible and generically available. So for example, nowadays, when we create a model, we almost always create a template for that, as you saw, we had a virtual network and virtual network template. We actually have a MPLS site template. So that kind of provides a flexibility for users to modify use the models for different use cases without the need of code changes. I think that was it. If you got inspired and haven't already, start to explore the higher levels of abstractions, and you will find them useful. Thank you.
Thank you very much. Do we have any questions? Alexi. And can you give your name and affiliation, please?
Going to stay for dinner and the sauna, because if I want to ask something more, intricate, I'll have more time asking it there.
Unfortunately not, but we will stay for a while after the event here.
Cool. Oh yeah, and you've got a colleague here, don't you?
Yeah, I hired him 4 months ago.
Do you, does the colleague want to stand up?
Yeah. He is the one who writes the code. I just define.
Any more questions? I have a quick one to the audience. Is there interest in more Nautobot type talks? Because they are relatively popular elsewhere. I think this is the only one we've got here.
Did you say Nautobot?
Well, Nautobot.
Netbox.
Well,
oh, yeah.
Yes,
yeah.
I think there's a third one as well. But I mean, all of the three.
Yeah.
I mean, the whole general source of truth systems, is quite popular. But I think this is the only talk. So if people would like to submit for next year, I think there is interest.
Yeah, maybe a short comment to that. So why we choose Netbox and in general source of truth system is that we wanted to create multi-vendor, even multi-domain automation. So we didn't want to stick with just one, and you don't get that so easily elsewhere. So that's why we did it.
Okay, another one from Max.
So I'm Alexi from Tampere again. So have you actually compared Nautobot and Netbox and some other similar systems? And what was sort of your feeling or finding? Why did you pick Netbox over the others?
I wasn't around when that decision was made.
Right.
I have been asked that question many times, and we have done some evaluation. There are differences. We were a couple of weeks ago at Prague in an AutoCon event, and I would say like 70% of people are using Netbox, maybe 15% Nautobot, and then InfraHub and others are the minority. Yeah, they took a little bit different directions. That's I'm aware of, but yeah, I'm not maybe
the right person to ask.
The right person to ask. Yeah, maybe.
Thank you.
Thank you.
And question on the side.
Tuomas from Telia. So basically your philosophy is not to reconciliate any conflicts in the network. So you basically build a template and just push it to the box and overrule anything that is in the box. So have you had any thought about should you reconciliate the conflict differences or conflicts there? Or you just overwrite everything? Because well, if there's like a brownfield node that is not fully automated, and then you have some services, so perhaps some infra stuff that is automated. So how to migrate your existing network.
Yeah, we have done that many times, and that's heavy work. But I'm kind of a fan of one-way pipeline still. Like, it's heavy work, but it's worth of it. So basically what we do is that we generate the configurations from the netbox, and then we fetch the configurations from the devices and show the difference. And there are thousands, maybe tens of thousands of lines in the first place. And then we just start to work on that until we are comfortable to push. And so far it has been working strategy. And after that first push, we are in sync. So people are asking a lot of, should we do a discovery? For me, it's a kind of a more pain, discovering something inconsistent. We can maybe have a tools to help on that, but still. So our reconciliation is based on the human seeing those diff lines and then resolving that.